Good morning, guys. So we'll continue unit number 4 next video. So last video we discussed about types of CMM based on structures like bridge type, cantilever type, column type, horizontal arm type like that we saw, and also portable CMM along with optical CMM. Each types might have special advantages or disadvantages. So in this video, we'll be discussing some other concept related to CMM. So under CMM, this one from this itself, you can know that it is a table. It's a granite table. So mostly in CMM machine, they'll be using either granite table or steel plate. So mostly granite table they prefer. So even in our lab, you might have witnessed granite table only. So here, lots of holes. It's not holes. We can say it is like a location of slaw hole with the MI threads. So using that we can able to mount the uh, workpiece which we want to test. So this is the granite table. It comes with the different sizes. So it has some of the features. So this should be structurally and thermally stable material. It should withstand some load which we are going to keep. Sometimes engine block we can keep above this granite table. So structurally it should be stable, and also thermally also it needs to be stable. Then it should possess low porosity. If porosity is there inside, when we make this kind of threaded portions for keeping the workpiece or some fixer jigs and fixes if you want to place it, then we use bolts to mount over here. So if there any porosity, we when we make this kind of holes, because if you want to thread in this, first you have to make a drill and then only we make a threading, right? So that time if porosity is there inside that granite, then crack and failure will happen. So low porosity should be, and low moisture absorption. It should not absorb lots of moisture because it will be comes under controlled environment, and moisture should not be absorbed. So if moisture absorbed, it may try to expand or something. So should be avoided. And low coefficient of thermal expansion. So thermal expansion in the sense it should not react with temperature changes, and it should not change its sizes with respect to time. So when changes in temperature happen, and it should not change its sizes with respect to time. So it should be very very low. Then only if it is very high, then changes of shape or some particles will expand big. So low coefficient thermal expansion in the sense with respect to time, then temperature increases, there should not be any changes. It should be very very minimal or low. That's why low coefficient of thermal expansion. If some component or object with high coefficient of thermal expansion in the sense with respect to temperature and time, the size of the object will change immediately or quickly comparatively uh, with comparative with the low that component with parts with the low coefficient of thermal expansion. So always this kind of granite table should possess a low coefficient of thermal expansion, and also it should be superior in terms of strength, and it should possess uniformity of texture. It doesn't matter, but when you use yeah, like textures, uniform structures, when you measure using kind of optical non-contact type inspection using this same CMM, then the texture will play a vital role, and also non-glaring surfaces is much needed. Once you use non-optic type or sorry non-contact type inspection techniques in CMM, like using white lights for scanning purpose. Probing purpose may be different, but for scanning purpose, you need a uniform texture and a non-glaring surface. As I said, M8 thread table inserts. It should have insert where you can able to have a threads. It's the size of M8. So this is the purpose of granite table. Mostly, maybe you know that in moving table or moving arm, they had two types like top mounted, side mounted. So in that, maybe inside they might have has having guideways, but in top mounted means half of the play that top that CMM structure will placed. But here, this kind of thing will be used in our lab. So this is like a fixed table and moving bridge type only. This diagram shows. Maybe in our lab also, table is fixed, bridge is moving. As I said, one end will be having the air bearing system, a drive system is there. Then next one is will be next to pillar, vertical pillar or column, you can say, will be acting as a slave. It will be silently moving along with the movement of the left side drive controlled column. Okay, so this is all about granite table. This is one of the main features in CM. Then how the operations and programming is being conducted. The positioning of the probe relative to part can be accomplished in several ways. Multiple ways we can try. What are the ways? Either through manual operation and direct computer control. Directly, like as I said, this CMM also considered as a modern industrial robot. In industrial robot also we'll be having various method to control the industrial robot. Start with manual to computer controlled one. So similarly, in terms of CMM also, positioning the probe is very very important. That how we can able to position the probe is through manual operation or direct computer control. We'll explain about this in detail in the coming slides. So computer controlled CMO operates such like a CNC machine tools. In CNC machine also, it will be running same manner only. So here CMM also needs to be programmed properly according to what kind of positioning we are planning for the particular probe, or if it is a moving table, how we are positioning the table in the measuring volume. The methods available, as I said, various methods available, four different types of methods available. Start with the manual drive. Second one, manual drive with the computer assisted data processing. So only for data processing, computer assisted data processing, but manual drive. So manual drives are two types. Manual drive, in the sense purely it will be using only manual calculation, manual data entry and all. But manual drive with the computer assisted data processing is data processing happening through computer. Motor drive with the computer assisted data processing. Driving also done automatic way, like a driven with the computer assisted data processing. The final one is direct computer control DCC with the computer assisted data processing. So these are all the four types. Under the direct computer controlled with the computer assisted data processing, you will be having another two types: manually through method and offline programming. So this kind of type same in our industrial robot subject also, you will be having this kind of types because it's a similar kind of robot or CNC machine or CMM. All will consider one category in terms of mode of operation. So we can classify as a manual drive with the computer assisted data processing, motor drive with the computer assisted data processing, and DCC, direct computer controlled. Under that, you have manual lead through method, offline programming. So what is manual drive? So in manual drive, it has a free floating probe, right? So maybe it joints and links, different joints and links are available in industrial robot. Similarly, in CMM also we'll be having different joints and links. For example, I don't know. Yeah, I have added a figure here. For example, this is a robot. Here you will be having links. This is joints, and this is also link. Here also link, and end of arm or end effector will be connected. Here joints, one, two joints. Links are one, two, three. Like starting with zero, one, two, total three links, and base and ground. So based on this joint, you will be having different kind of degrees of freedom of movement. So under that, if you have a different joint, you will be having different types of motions. What are all the motions? Translational motion and rotary motion. So under translational motion, in the sense you will be having linear joint. So this is the linear joint. The first one is the linear joint. Uh, then second one is the orthogonal joint, which is represented in terms of O. linear joint represented in L. So these are all the standard notation used in industrial robot. But in CMM also similar kind of joints and links will be there. So that's why I want to add this point in this place. So linear joint, orthogonal joint. Linear joint represented in this. So input link, output link. So it will travel in this only in linear. But orthogonal in the sense input link in one direction and output link in the another direction, like a 90-degree will be there. Then this all both are considered translational motion. But rotary also available. In terms of rotary, you will be having rotary joint represented with R. Based on this pivot, this joint, your output link can be rotated in this axis, rotary joint. Twisting is possible. So twisting also possible based on this particular. Here is the input. Output link can be twisted. So accordingly, some mechanical system, the gear mechanism system, rack and pinion type or rack type will be here. And similarly here also each and every place some mechanical arrangements are there. Then revolutioning joint, revolute joint. Excuse me. Revoluting joint, it's represented here, input link and output link. They also completely rotational, output link completely rotational. So these are the joints and types of motions available in industrial robots. Same can be implemented or adapted for CMO. So you have to remember totally two types of motion, translational and rotary. Under translational, you have the linear joint, orthogonal joint, representation of letters L and O for linear and orthogonal, and diagram is here. And for rotary motion, you will be having rotational joint represented with R, and twisting joint represented with T, and revolving joint with V. So each diagram is available here. Linear means like this, input and output, and the next one is orthogonal. Action is moving like a output link, orthogonal 90-degree. Then rotational joint, the input link and output link like this. Then twisting joint, finally complete revolution based on this input link axis is your revolving joint. And here you will be having the joints and links, how it is connected. There is a ground base, this called as a link, and this is called as a joint, and this is another link here also joint. Here you will be having the end effector. End effector will be designed or decided according to the what kind of product or object we are going to handle, whether it's a glass type or just two fingers are enough to pick something, like different grippers we can keep. So depends on the nature of component we are going to handle or testing, we can. Otherwise here you can, instead of end effector, you can keep the probe for measuring purpose or scanners for measuring purpose. Okay, so this is the control mode of operation for CMM. So what we studied is the manual drive. CMM has a free floating probe. So as I said, at the end of your manual joints, instead of gripper, you can add the probe also. The operator, like a CMM operator, will move the uh, axis, he will be holding the end of what to say, end of the links, and when he move, it will be freely floating. You can move with the multiple axes, three axis also possible. Then you can move that and getting closer to, or make it closer to the object, and you can do start measuring the features available in the part or object. Then data points or data clouds will be prepared, and we can measure. But that is computer supported process, data processing. But manual drive in the sense you have to take the position and you have to note down and process in future. So this is what your CMM controlled one. Difference among the contact position or the measurement. So if you measure it in one location and moving to another location, one after another, you will be getting different types of coordinates. Okay, but that is too difficult to, what to say. If you have multiple points or multiple features, then it is difficult to collect all the data and process. But manual and computer assisted in the sense, you will be having a display. You will be having a electronic digital display in this machine. So you can able to, for example, if you have the feature, same like other component like a piston, if you consider, When you are moving that joints which is having a probe closer to the piston or connecting rod or engine block, whatever may be the object, when you are moving, automatically there will be changes in the coordinates, joints and positions. But once you keep, if you keep one end of the object is the reference, like home position, from that you keep the probe, then you can make a setting of 0, then change of sign plus or minus, or you can change the unit difference like millimeters or centimeter or meters you can, and what kind of data you want to print you can do. So that support will be added in the second level, like a manual computer assistant. So basically, it will save lots of your time when we take the data, and it will minimize the calculation, reduce some error. So what is minimize? What is minimized calculation in the sense, since data are processed automatically, that like addition of data, subtraction of data. For example, as I said, if you have a probe of sphere type, then the diameter you have to consider, because measured length is different and the nominal length is different. So you have to adjust it, right? So that calculation you can able to do it in the computer assisted programming itself. So it could also reduce calculation errors. So manual with computer assisted. It's the second type. Third one is motor computer assisted. Even the movement of joints and links not done by manual operator, it will be performed using joystick. In our robotics lab also we have a teach content. In the teach content also we have a joysticks. So using joysticks we can able to move the axis. Means you are giving inputs to the axis, in the sense what joints and links will coordinate, and it will move properly according to the commands being given from the joystick. Then joystick, using joysticks you can move the probe closer to the object and you can perform the measurements. Okay. Then data points will be stored in the computer, and further processing can be possible. This is the third type. The final one is a direct computer controlled DCC. It is the utmost automated one. Maybe in Industry 4.0, people are using this kind of things only. They are expected to use only this kind of thing. But as I said, people now started thinking about Industry 5.0 also. Yeah, Industry 5.0, it's a personalization is there, but we don't think about Industry 5.0 recent time in our India. So India is implementing mostly Industry 4.0 only. So we are moving fast in this digital technology world. Industry 4.0 only. That this direct computer controlled CMMs are fully used, fully programmable. This is, you have to program each and everything, and also you can use the CAD data, that the 3D model of the data you can feed it in the software, which using the data, the probe will analyze the coordinates of the component with reference to the uh, its working space. Then the probe will move according to that the data, CAD data, then measure the various points from the component. Okay. So here you can, using that through programming, you can able to place the workpiece properly on your fixture or work table, and also you can run the program. You can store the program according to the which kind of product you want to or object you want to check, and you can collect multiple data, and also you can prepare automatic report. So in that you will be having multiple controls, movement control like moving the x-axis, y-axis, z-axis, or do some your pitch, yeah, rolling, like a degrees of freedom. We can able to movement control, and also you can perform measurements and also perform the formatting application also. So measurement and movements are main. Then formatting is the data processing. It will come. Okay. So as I said, these are all the four types of mode of operation: manual drive with the computer assisted data processing, motor drive with the computer assisted data processing. The final one is direct computer control with the computer assisted data processing. Okay. Under that, manual lead through method, offline method. So in manual lead through method, in the sense, so initially you will be taking your arm, CMM arm, and travel with each and every position. For example, engine block top, you want to measure that, what to say, diameter of your code or distance from one end to another end, everything you cannot trace the full profile. So you can take give the guidance to the probe by yourself. Then automatically, then program will be processed in the direct numerical control. Then simultaneously you can run. And otherwise, with the 3D model inside your database, you can write programming through some robots studio software kind of thing. In CMM also, you will be having inbuilt software according to the type company which providing the CMO. In that, you can able to write some offline programming. Then you can run. Then automatically your probes or table will move according to the inputs. Then what are the applications we have for CMM? So CMM coordinate measuring machine find application in many, as I said, in terms of automobile industry or aerospace industry, paper industry, or we can say medical industry or healthcare, okay, or semiconductor industries like that. So mainly automobile, machine tool, electronics, space, and many other large companies where you need a geometrical accuracy. Okay, you need mainly about your dimensional accuracy is very, very important. Functionality depends on the dimensional accuracy. So wherever the dimensional accuracy is important, you have. And again, the other points we discussed, like it should be flexible. It should also personal reduce the cost for unit cost, and also short run means keeping one primary factor is a main objective. Like dimensional accuracy as the primary factor, it should run. So CMM plays a vital role in multiple places in this kind of industries. So these machines are best suited for the test and inspection of test equipment, gauges and tools. So if you want to do inspection or test of the equipment being fabricated or manufactured or prepared or gauges, you can able to use. For aircraft and space vehicles, 100% inspection is carried out by using CMM. So mostly they will be, because the accuracy and precision is very, very important in terms of these industries. If any small failure happen, it cause too much of damage or issues. So you have to have a proper inspection technique. So they will be going with the CMM, mostly DCC, computer controlled programming only. They will be trying dimensional accuracy of the component. As I said, it is very, very important. So conventional, comparing with conventional metrology, CMM will be preferred, but it depends like how much facilities we are having. So this CMM also ideal for determination of shape, position, maximum material condition, linkage of results, etc., which cannot be done using conventional machine. Where you can't able to control perform using conventional machine, you can able to use uh, coordinate metrology. Then CMM can also be used for sorting tasks to achieve optimal pairing of components with the tolerance limit, like a kind of machine vision. If you are adding some camera or machine vision system in the CMM, then it will be performing the sorting operation and also grouping of the components. Maybe we understood about interchangeability and selective assembly concept. Okay, so in one of the concept we discussed about 1,000 components if you take, and in one lot another lot also having 1,000. If you take any one from lot A and should be needs to be assembled with the lot B, it is highly difficult because you need special purpose machines to achieve 1,000 components in same tolerance limit. But another concept we understood is any component you can take and you have to group it. You have to group it. For example, tolerance with is plus or minus zero point 0.2, plus or minus 0.2, one group, plus or minus zero point 0.1 is another group, plus or minus 0.15 is another group. Similarly, in lot B also, similarly you can group it, and smaller to big, bigger to smaller, you can assemble. Okay, so that is what. So for that, you need to shorting that group into multiple levels. For that, you can use this CMM or machine vision system, and then once you sorting is done, you can able to plan for assembly. Same also best for ensuring economic viability of NC machines by reducing their downtime for inspection results. Okay, so as I said, uh, production interruption needs to be avoided in the sense like a machining center needs to be properly controlled by CNC machines or NC machines or CMM, so that downtime of the machining center will be avoided. Because if you are inspecting and the rework is doing, in the sense during inspection if any error, then rework will be done in some other machine, means continuous production will be stopped. So you need to avoid the downtime. So CMM will provide in each step. If we started using from the beginning, we started using CMM, then the downtime will be reduced. So it will be producing better results, so that you can reduce the cost on the product unit cost. So that's what it is, reducing cost, rework cost at the appropriate time with a suitable CMM. So appropriate time is very very important. You have to use properly. Then other applications, metrology useful for linear measurement, angular measurement, geometrical feature, profile checking. So linear measurement in the sense measured and constructed feature, and angular also measured and constructed feature, geometrical feature, profile checking. For that, metrology CMM process application and inspection also you can receiving in process final. You can do multiple inspection, mode of inspection either manual or automated. Automated means DCC, direct computer control. Purpose of inspection, first piece approval, or where we are implementing the CMM, whether in the initial stage itself or in the during process control or before pre-assembly, or if we are using this for reverse engineering purpose. Reverse engineering purpose in the sense is not probing, it is scanning. Okay, probing is measurement and gauging, but reverse engineering means mostly comes under scanning. Location of the inspection, whether under the standard room environment or a machine shop or on-site. On-site in the sense you can't able to take gantry type or other. You can able to take portable CMMs in on-site. Machine shop also you can take a portable one. But a standard room in the sense other type, like bridge type, gantry type, moving arm or cantilever type, we can able to. Because that will be affected by the vibration. So you have to have a particular meteorological lab setup for protecting that instrument uh, being reacted with that environment, and it could lead to error. So we need to avoid that. For that, you need some special location. So based on location, also we can classify. You can use other advantages. The inspection rate is increased. If you want to increase inspection rate, particularly with machine vision, we can increase comparatively higher accuracy. Operators error can be minimized, particularly comparing with conventional metrology. This coordinate metrology will be providing less errors only. Means operator needs to be trained. If you say advantage, but simultaneously you need to spend some time and money or resources on operator to give them training to operate this kind of machine. So this also involved. Still, skill requirements of the operators is reduced. It looks like a reduced in the sense they will be doing monotonous of operation, even though in CMM, because mostly they pre-programmed. Once pre-programmed in the sense just to run the program control in that sense. But initial investment for training is needed, or initial setup is needed. Setuping the CMM machine for inspection are much needed. But monotonously, they are mounting the workpiece on the table and turning on the program, means automatically CMM will run the program A, B, C, D like that. A, B, C, D in the sense measuring the whole features, or measuring the width feature or dimensional feature, form features like that. Everything needs to be programmed and given, means just the unskilled operator is sufficient to just loading and unloading. Then he will be only turn on the program on off like that. Then it will be performing. Reduced inspection, fixed turning and maintenance cost, reduction in calculating and recording time, reduction in setup time, all only through computer assisted programming. You have to have a pre-programmed. Then we could able to save lots of time. Okay, no need to separate go or no go gauges for each. Yes, because the probe is doing all the purpose. So separate go or no go gauge is not needed, because the go gauge, no go gauge will comes under conventional metrology, not in coordinate metrology. In coordinate metrology, if we started going, depends on what kind of probe. So types of probes also there. So we'll discuss about the types of probe and application and what is what in the next video. reduction of scrap and good product rejection. So you can reduce lots of waste, because if you invest or initiate the CMM measurement in the initial stages itself, you can reduce the scrap, or you can reduce the reworking, or you can reduce the downtime of the machine centers. If you implement the CMM in the beginning stages of that, reduction in offline analysis time. Yes, all will comes under advantages of CMO. Disadvantage, of course, since it's a computer controlled probe based in the sense, it depends on your XYZ axis movement, or pitch or roll movement, the degrees of freedom. So it's all comes with the servo control, or it will becomes under air bearing type. So if any alignment issue or any motor, servo motors, or your bearings are not functioning good, it will lead to some error, like orientation error, or the probe is not placed properly, then probe alignment error will come, probe offset possibilities are there, or run out. Then, since it's only based on x-axis, if most of the type of CMM, like a bridge type, cantilever type, or moving arm type, all thing, all column type, all vertical, but only moving arm as the probe with the horizontal axis. Okay, horizontal axis one. So in that only you will be having different error, but other type you will be having the perpendicular error. Okay, and if it's all computer controlled one, if something went wrong in your programming, then it may lead to some errors. So these are all the basic disadvantages. Then the cost and the time needed for training the operators, skilled laborers are needed for initial programming and all. After that, it will be leading as a advantage, but some disadvantages also will be there. Okay. So next is probe. So we can continue about the probes in the coming video. So what are the point we have discussed in this video, to just recollect. We discussed about CMM features and that granite table. What is granite table? What are the important characteristics it should possess? We have discussed, and how the probe wing are positioned. So in that you will be having four types: manual drive with the computer assisted, motor drive with the computer, or DCC. Each one we discussed in detail, and also what is joints, what is links, what kind of joints, translational motion and rotary motion type joints are there. Under that translation, you have linear and orthogonal joints. Under rotary, you have rotational joint, twisting joint, revolving joint. Though this comes under industrial robot, but in CMM also you will be having, instead of end form or gripper or some other manipulators you are keeping, you can keep the probe. Then we can consider this as a CMM machine. Then application of CMM, various application, and also some of the advantages and disadvantages of CMM we have discussed in this video. I'm closing this. We'll continue in the next video about the probe. Okay.